Good morning, everyone. Very good morning to all of you. So I hope you people are doing good. Yeah. So in yesterday's class, we have been discussed about the channel transitions, and we have completed the specific energy topic. I hope you people have gone through the classroom notes. So yesterday we discussed up to these conditions: the channel width reduction and channel bottom rise, and you know that out of those, so which one is going to be the important one? And apart from that, yes. So now you know that channel bottom rise and channel width reduction both are going to be similar to each other, and they are the ones which are going to have the choped conditions. Yes. Now let's see the remaining questions. Yeah, yesterday we saw this question number 15, and I hope you understood that question. We have been approached in a different ways, and this is regarding to the channel bottom rise. Now let's see double transition. Let's see the double transition. See, we have seen a single transition. Analysis is for the single transitions. Now, in the numerical analysis, we are going to discuss about the double transition also. Now, let's see this question. Question number 17. Question number 17. So, have a look about this one. The width of a rectangular channel is reduced from 4 meters to 3 meters at a transition. The width of a rectangular channel is reduced from 4 meters to 3 meters at a transition. So, the width has been reduced from 4 meters to 3 meters, something like this. So width B1 is going to be 4 meters, reduced to B2 as a 3 meters. Now, if the depth of flow upstream of the contraction is a 0.9 meters, see, this is a contraction. What is the meaning of contraction? Reduction in the width. So if the depth of flow upstream of the contraction, whatever the depth of flow upstream of the contraction is a 0.9 meters, now observe the question carefully. The change in bottom elevation required to cause zero change in water surface. What is the meaning of that they are asking? See, they are asking about the double transition. Yes or no? Now, you know that if it is a single transition, means whether it is a channel width reduction or channel bottom rise or drop, you know the water level may rise or may fall. If it is a subcritical flow, it should fall to critical. If it is a supercritical, it should rise to critical. But now in this question I am asking you, how much change in the bottom elevation? What is the meaning of bottom elevation? Channel bed. How much I have to rise or drop the channel bed so as to make sure the water surface remain horizontal. To make sure the water surface remain horizontal. You see, this is what I am asking you. So I don't want any change in the water surface elevation. So the meaning of elevation means from the normal datum to the water level, which means the water level should remain constant. Now, the question is, how much change? And in the given question, did they mention anything regarding to whether the channel bottom elevation rise? No. Channel elevation drop? No. They just asked the change. So we don't know whether it is going to be rise or drop. Okay. we don't know whether there is a rise or drop. See, this is a very good question. First, let us solve by means of numerical, and then we solve it by means of the analytical procedure and what are the conclusion points also. Please have a look about this one. So, yeah. So now let's assume channel bottom rises by delta Z. See, I am assuming because I don't know whether it is going to be rises or drops. I don't know. So what I am going to do is I'll just simply assume. If I assume it as a delta Z is going to be rises. Now let's see, my dear. So this is delta Z, and whatever the water depth, initial depth, this is Y1, and for no change in the water surface elevation, this is going to be Y2. Okay, no change in the water surface elevation means now Y2 plus delta Z. So which means now for no change in water surface elevation, for the no change in the water surface elevation, we take y1 is equals to y2 plus delta Z, and given y1 is equals to 0.90 meters. So now repeating the question once again. So in the given question they mentioned width has been reduced from 4 to 3 meters, and for no change in the water surface, how much channel bottom should change? As we don't know whether the channel bottom rises or drops, what we do is we assume the channel bottom rises by delta Z. Now, when we assume the channel bottom rises by delta Z, now if I get the delta Z after calculation, I get the delta Z as a positive, then I can say the assumption is correct. If I get the delta Z value is negative at the end, then I can say the assumption is going to be false. Okay. Now let's see. You know, whatever this is nothing but the total energy line or not. Whatever this is nothing but the total energy line. Now, my dear, does it just looks like a uniform flow? Because you see, okay, fine, forget about that first. So you get down the relation between the specific energies now. You get down the relation between the specific energies. What is this? Here this is a specific energy E1, and here this is a specific energy E2. Okay. So now from the specific energies, I am using these relations from everywhere. So now relations are E1 is equals to E2 plus delta Z. I hope you understood this. E1 is equals to E2 plus delta Z, whereas a Q1 is different and Q2 is different now. Now E1 Y1 plus V1 square by 2G is equals to Y2 plus V2 square by 2G plus delta Z. But you know that y2 plus delta Z is nothing but y1. Yes or no? Y2 plus delta Z is nothing but the y1. When y2 plus delta Z is nothing but y1, y2 plus delta Z both are going to be gets cancelled. Then v1 square by 2g is equals to v2 square by 2g. Then from here, velocities are going to be same. So now you tell me, whenever the flow velocities are going to be same, can I say that flow as a uniform flow? Yes or no? If you are smart enough, you can represent those things directly here itself. My dear, you see, whatever this is nothing but V1 square by 2G, and whatever this is here, V2 square by 2G. Yes, whenever there is no change in the water surface elevation, whenever there is no change in the water surface elevation. See, elevation means from the bed level, my dear, from this is a datum, from the data. So for no change in the water surface, now TL is also going to be horizontal, and this is going to be horizontal. V1 square by 2g, V2 square by 2g, both are same. Velocities are going to be same. Now, what I can say, the node point here is, what I can say, the node point here is, when water surface when no change in water surface elevation, velocity of flow remains same. Velocity of flow remain same. Now, velocity of flow is going to be remain same. Now, V1 is equals to V2. Yes or no? But what I required is, see what I'm asking you here. What I'm asking is this delta Z. Yes or no? So how come I find out this delta Z, sir? I know this relation. And in this I know Y1. What is the Y1 value? 0.9. So if I can find out Y2, I can find out delta Z. For this, what I do is from continuity principle, from the continuity principle, you know, Q is equals to A1 V1 is equals to A2 V2. Velocities are same. Here, please. What is B1? 4 into Y1. B2 3 into Y2. Okay. 4 into 0.9 is equals to, okay. Now, yeah. 4 into 0.9 is equals to 3 into Y2. Okay. So now, my dear, from this we can solve this Y2 is equals to 1.2 meters. From that, we are going to solve Y2 is equals to 1.2 meters. Okay. Now, from the relation Y1 is equals to Y2 plus delta Z. See, I assumed the channel bottom is going to be rises by delta Z. So that's the reason why I got this Y1 is equals to Y2 plus delta Z. Then what is Y1? 0.9 is equals to 1.2 plus delta Z. Now what is delta Z? The delta Z is nothing but minus 0.3 meters. Everybody have a look now. What is the delta Z I got? Minus. Because I assumed the channel bottom is going to be rises by how much? Delta Z. I assumed the channel bottom is going to be rises by how much? Delta Z. So as I assumed rise, so the value that I got is a minus value. So what is the actual? The meaning of this one is a 0.3 meters drop. This is a minus 0.3 meters rise, which means 0.3 meters drop. Now you tell me what is the actual transition that I am seeing over here is, it is not a channel bottom rise. It is a channel bottom drop. So our minus comes means our assumption is false. So that minus is rise, and if I take it as a plus, that is going to be the drop. Okay. I hope you understood this. Now, the next conclusion is, what is the first conclusion I have said? When there is no change in the water surface elevation, velocity of the flow remain same. So this is the first conclusion. Now, the remaining second one is, you see, I'm asking you a question, please listen and listen. If it is a single transition, does the water surface elevation remain same? If it is a single transition, does the water surface remain same? No, and never it is going to be same. But why the water surface remains same over here? Due to double transition only. So water surface remain horizontal if and only if there is a double transition. Okay. Now, if and only if there is a double transition. Now, what are the possibilities of those double transition? See, the possibilities of those double transition. See, what are the meaning of double transition? There is a change in the width and there is a change in the channel bottom. Yes or no? In the width, the width may reduce or the width may expand. In the channel bottom, the channel bottom may rise or channel bottom may drop. So total 4 transitions are there. Yes or no? Now you see what is the condition I got over here. One is going to be, if width is going to be reduces, then the channel bottom should drop. Yes or no? Okay. Now you see, when there is no change in if you want to make sure there is no change in the water surface, you must make sure there's a double transition, my dear. Okay. Now in the double transition, there are width, there is a channel bottom, and from this example what I got to know is, if the width is going to be reduces, the channel bottom is going to be drop. What is the meaning of over here, sir? Sir, what is the meaning of width reduction? Is it a choked condition or no choke condition? Choked condition. Yes or no? Is it a choked condition or no choke condition? Choked condition. Because when the width reduces, there is a possibility of the choked condition and you cannot reduce the width less than BC. And what about the drop, sir? What about the drop? The drop is going to be choked condition or no choked condition? No choked condition. Because you can drop to same amount. See, when you reduce the width, the water level will fall. And when you raise the drop, when you provide a channel drop, water level will rise. Both are going to be interlinked, and then the water surface is going to be remain same. What I want to say at the end is, if you want to go for no change in water surface elevation, either you provide a no transition at all or you provide double transition. Two options, either you don't provide any transition or you provide 2 transitions. And in that 2 transitions, one should be choked condition, other should be no choked condition. Means one channel transition should cause a critical flow, other should not cause any critical flow. Then only those are going to be overlap and causes no change in water surface. Now, note point. For no change in water surface elevation, double transition should exist. Double transition should exist. So based upon that, if I say the double transition, what are the conditions? See, for the channel transitions, they don't need to mention about assume channel frictionless, horizontal, and something else. For the channel transitions, which concept we are using? Specific energy. And for the specific energy, what is the common assumption? Channel bottom is horizontal and frictionless. So they don't need to mention every time, now and then. Double transition should exist. No. Yeah. So what are those? Now let's see. Conditions in the plan view, in the plan view, and in the elevation view, in the elevation view. So condition number one, condition number one, if you want to make sure there is no change in the water surface elevation, double transition should exist. And from this example, I can say channel width is going to be reduces and the channel bottom is going to be drops. So from the given question, I can say the plan means width, reduction, and the elevation is going to be drop. Plan means this is width by width. This is channel bottom, this is going to be the width. Okay. The other condition is going to be, see, now I want to make sure if I want to rise a channel bed, if I rise a channel bed, rising of channel bed causes critical flow. And the other transition should not cause any chokeout condition. So width should be expand. So now the other one is if width is going to be expansion, and elevation should rise. So for these only the possibilities are going to be there. This is a possibility one and this is going to be possibility two. Then only there is no change in water surface elevation. And from here onwards, whenever you see a question with no change in water surface elevation, then you simply make sure veloces are going to be same. You simply make sure veloces are going to be same. When veloces are same, from continuity principle, you can find out the remaining things. Yeah. Now that's it about this question. Give me a minute, please. Yeah, that's about this question now. Let's see. So next question. Yeah. And there is one more question. And this exactly predicts the actual behavior in a reality, this question. Now you please have a look about this question. A rectangular channel of width how many meters? 2.4 meters. A rectangular channel of width how many meters? 2.4 meters. Changes to trapezoidal section in a transition. Changes to trapezoidal section in a transition. So the width of the trapezoidal is going to be 1.8 meters. The width of the rectangle is going to be 2.4 meters. Okay. So along the length, now the rectangular channel is going to be changes to the trapezoidal channel, whose width is going to be changes from 2.4 to 1.8 with the side slope as 1:1. The depth of flows are 2 meters and 1.6 meters in rectangle and trapezoidal sections respectively. So they have given the rectangle and trapezoidal sections depth of flow also. What is the depth of flow? The depth of flow is going to be 1.6 meters and 2 meters respectively. Now, the discharge in the channel. So what is the discharge I mentioned here? The discharge in the channel is going to be 12 meter cube per second. Neglecting the frictional losses. Neglecting the frictional losses. See, if I neglect the frictional losses, then total energy line is going to be horizontal. The rise in the bottom level through the transition is. So, they are giving both the transitions. Now, I hope you remember one of the figure that I have been explained for you. Yeah. I hope you remember this figure. You see, this is nothing but a rectangular channel, Adnan. Yes. Now, this rectangular channel is going to be changes to that trapezoidal channel in the same question I have mentioned. Yes. And here, what is the width of the rectangular channel? I have given there some 2.4 meters. So 2.4 meters to the width of the trapezoidal channel as a 1.8 meter, my dear. And this is going to be having some side slope, one vertical to m horizontal, that is 1:1. It has been mentioned. And there is a level of water in the rectangle and trapezoidal they have mentioned. And what is the channel bottom rise it should require? What is the channel bottom rise it should require? Okay, fine. Now let's see how the transitions has been done. At first, the channel is going to be a rectangle, and I have provided you the rectangular details. What is the rectangular details? Y1, and this is going to be B1, and then it is going to be changes to trapezoidal. And what is the width of the trapezoidal section, please? The width of the trapezoidal section B2 is 1.82 meters, 1.8 meters, and it has some side slope, one vertical to m horizontal. And what is the depth of flow? Y2. So given details are, for rectangle, B1 is equals to 2.4 meters. Y1 is going to be Y1 is how much? Y1 is 2 meters. And trapezoidal B2 is 1.8 meters. Y2 is equals to 1.6 meters. And side slope M is equals to 1. So I know the discharge also. Neglecting the frictional losses, the rise in the channel bottom level. So every time, keep that in your mind. Step number 1, every time they give a question regarding to channel transition, you draw the elevation and the plan. And then you apply the relation between the specific energies. Then you apply the relation between the specific energies. Now what I'm going to do is, the width is going to be changes in the plan view. I cannot see the cross-section shapes. I can see only whether the width is going to be reduces or not. Yes or no? Okay. So this is a plan view. Whose width? This is B1 as a 2.4 meters. Reduces to B2 as 1.8 meters. B1 as 2.4 meters and B2 as 1.8 meters. Okay. Now, what happens to the channel bed rise? I have mentioned clearly the channel bottom to transition. What is the rise, right? So now, how much rise should be there over this transition? How much rise is going to be there over this transition? And they mentioned that it is going to be frictionless. This is a total energy line. And now you see they have given the depths of flows in both the cases. This is a total energy line. They have given the depths of flows in both the cases. But I don't know whether this is a double transition or single transition. This is a double transition. Yes or no? So in the case of the double transition, can I say directly does the water level rises? No. Can I say directly does the water level is going to remains constant? Now you see, this is a width choked condition and this is a channel bottom rise. Again, that is also choked condition. When both the choked conditions are there, do you think the water surface remain horizontal? No, my dear. Water surface will not remain horizontal here because one is width reduction, other one is channel bottom rise. So either the water level may rise or fall. I cannot predict that directly. So simply what I do is, can I write down the relation between the specific energies, my dear? What is the relation between specific energies? E1 is equals to E2 plus delta J. So the relation between the specific energies is E1 is equals to E2 plus delta J. That's it. So I'm not doing anything over here. I just draw the figure and I'm getting the relation. Now what I require is this delta J. This delta Z I require. So if I find out E1 and E2, then I can find out delta Z. What is E1, my dear? Y1 plus V1 squared by 2G is equals to Y2 plus V2 squared by 2G plus delta Z. Y1 plus V1 squared by 2G is equals to Y2 plus V2 squared by 2G plus delta Z. Now, do I have Y1? Yes. Y1 is there and Y2 is there with us. Now, if I want to find out delta Z, I need to find out V1 and V2, right? That's it. Now let's go back to the channel geometries here. So this is a section 1 and this is a section 2. Velocity 1, velocity 2. I know the discharge. Can't I find out the velocity? Please find out the velocities. Please find out the velocities and let me know. So what is area over here? 2.4 into 2, which is a 4.8 meters square, A1. And what is A2? For trapezoidal, By plus My square. So 1.8 into 1.6 plus 1.6 square. So find out those values. Find out those values and let me know. So this is a 5.44 meter square. And now from this, what is velocity V1? 12 by 4.8. So 12 by 4.8, which is equals to be 2.5 meter per second. And what is V2? V2 is nothing but 12 by 5.44. which is going to be 2.2 meter per second. So now you see, so I have given this V1 and V2. Once you know the V1 and V2, you please substitute over here. What is the Y1, my dear? What is the Y1 I mentioned? 2. What is the V1? 2.5. 2 plus 2.5 square by 2 into 9.81 is equals to, what is Y2? 1.6 plus, what is V2? 2.2. 2 into 9.81 plus delta Z. So you find out and let me know the delta Z value. That's it. These are the steps, sir. See, I'm taking more time to make sure understanding of the question. You need to understand the question, and once you understand the question, then you can find out the delta Z. Can you please tell me what is delta Z value? Please tell me the delta Z, no? It's going to be 0.471. And if I ask you round it to 2 decimals, 0.47 meters. So you are going to raise the channel bed by 0.47 meters. This is a double transition or single transition? Double transition. Here the discharges are, so discharge per unit width, our velocities are going to be different. Okay. I hope you understood. If you have completed. And one more thing I want to say. So still, if you want any of your friends, like still some of the people would be there, the new batches are joining. And if any of the people of your friends who are working so that they cannot attend the online classes. So you know that the ACE has a other platform known as a Deep Learn platform, which is a recorded videos session. So there also the concepts has been see, and you know what, for the recording sessions it took more time than the online classes. It took more, the content is same, but it took a very lot of, means a large time to go over there to explain, to make sure with the visuals and all those things. So that's a very good platform, and I can say that the 100% credibility over there, and whatever the quality they are going to provide also very good quality. So if any of your friends are interested, see, obviously the marketing is going on and the ads are going on, but it's not about like everything we get in online. It's about something like a more publicity. And you know, by this time, you know how the subjects are looking like. So you have been came across a lot of subjects, especially the batches are. So the batch that I have started with, the geotech completed, structure analysis completed, environmental completed, and open channel flow is going on. You know how quality the education here it is from us, means from the ACE platform. So if any of your friends are still interesting, because the July, means the ESC dates has been announced already. It was somewhere in July, and GATE dates has been already announced. So now we're in August, and we still have 4 months, means after August itself. So we still have 4 months in the 2020, and then so literally I can say 5 months are there. And if your students, if your friends are interested, already almost all the subjects has been uploaded in the Deep Learn platform. So you please let them know about the Deep Learn so that they can also get beneficial, because at this point of time, so if we launch the online classes also, it will be a time taking for every day. But if it is going to be a Deep Learn, that will be with you, and you can wake up at any point of time, you can sleep at any point of time, you can watch those videos, right? So for that, you don't need to wake up at around 6 o'clock to attend my class at 7 o'clock. For that, it's up to you. It's up to you. Whenever you want to study, you can study. Everything is there. and there are a lot of doubt clearing sessions would be there, just like how we are taking also. It's similar to what is happening now, and it is going to be time fetching for you. So any students or any friends of yours still interested, you refer them for the deep learn courses. That will be very, 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 very beneficial for them. Okay. When offline classes starts, this year, forget about the offline classes this year. So if that comes, that's good. If not, we cannot do anything better. So this year, possibility of offline classes are least. We cannot keep our hopes up, but as people, we are an optimistic nature. So we do think about the vaccine may come in October, September, December, January, February. We do think like that. But one fine day vaccine will come and the things will get normal on that day. But up to that point, we have to bear. Yeah, fee will be there that you can see in the website. What will be the duration? See, duration means for, see that is not like online classes, live classes. That's a recorded classes would be there. So already we have been recorded all those classes, whatever the classes. See, on the morning session, I'm taking class for you. And in the afternoon session, I'm recording those videos. So for the sake of the people who are joining for the deep learn. My friend joined ACE for AC only. Now he doesn't have it. Wow, very good, Ray. You please bring one more AC to your home. That's okay, fine. Now, that's about this. Tomorrow there is a holiday in the eve of Ganesh Chaturthi. Though we don't go out and we don't celebrate with means every year. We know that especially now in our India. So the first festival that we do is Ganesh Chaturthi, because so whatever the work we start every time, we used to worship God Ganesha. So and every year, especially whenever there is Ganesh Chaturthi, so huge statues we keep in every nook and corner of a street and major roads and something like that. So we used to celebrate and we used to do that festival for at least 9 to 11 days. But this year, due to pandemic situations and whatever the things that were going on, due to these pandemic situations, not only we degrade ourselves mentally, physically, and economically also, we are in a lowest state. So right now, some of your parents may be getting half of your salaries, and some of the parents might be getting less than that. And some of the people whom I know very well also, they lost their jobs. And some might be good, and those people who have already some financial things, they are good. But the people who depends upon, especially on their daily earnings, are the people who doesn't have much of their financial support. They are suffering a lot this time. So but anyways, instead of going out and doing large festivals, means large mob or crowd gatherings for the statues, it's better you please be at home and try to spend some quality time with your parents, with your mother and with your father and with your siblings. So help your mother for some cooking and be with your father, talk to them and let them know also. So spend a very good day tomorrow with your family, and that is very, very important. Whether it is a festival or not, it should be there. But when it comes to the festival in our India, the festival meaning itself is to celebrate, to be happy. So to make ourselves to be happy, yes. So don't go any out, don't be with your curiosities, because up to the last year we do have a curiosity, and actually I do also have that curiosity. So whenever there is a Ganesha statues would be there, Ganesha idols would be there, I used to roam in every street and I used to look what type of idol they have kept, what is the height of that idol, and how good looking it is, and all those things, and especially the prasadams also. So what type of prasadam they are giving. But every year that is a curiosity, but don't do that curiosity this year. Even if there are some idols in a street. You don't need to visit right now because due to the crowd gathering, there is a possibility you never know how this coronavirus may get uninfected to you. So please be safe and be at your home. Spend a quality time with your family and then study. Okay. So how much time will take for the OCF? It will take up to the point it takes. So don't worry, forget about that. Okay, now let's see the next some of the previous GATE and IS questions. You see this question, please. Yeah. You see here, when no external energy is going to be imposed, which means we're just allowing the flow only, which of the following statements would be true? Energy line always falls in the direction of flow. Energy line always falls in the direction of flow. This is due to head loss. This is due to head loss. So energy line is going to be falls always in the direction of flow. And second one, hydraulic gradient line never rises in the direction of flow. Hydraulic gradient line never rises in the direction of flow. Now keep that aside. So specific energy may increase or decrease in the direction of flow. Yes or no? I told you the specific energy may increase or decrease in the direction of flow because when channel bed rises, specific energy decreases. When channel bed falls, specific energy is going to be increases. So this is also going to be true. And energy line and hydraulic gradient line can cross each other. Energy line and hydraulic gradient line can cross each other. No, energy line cannot be cross each other. Energy line cannot cross. So hydraulic gradient line and energy line will never cross. Always hydraulic gradient line lies below the total energy line. And hydraulic gradient line never rises in the direction of flow. No, in the case of pipes for negative pressure, HGL lies HGL rises. So this is not going to be true. So what are the common things? Energy line always falls in the direction of flow. One, and specific energy may increase or decrease in the direction of flow. So answers are going to be 1 and 3. Now this year, the same type of questions they will give you in MSQ. See, this is ESA, my dear. In the GATE, this type of questions they will give as in GATE they will give as MSQ. So what they ask is in MSQ they will option 1, option 2, option 3 and option 4. Okay. So I'll give you the same thing. When no external energy is imposed, which of the following statement are dash? Yes, would be true. I'll give you which of the statement are dash S would be true. So I'll give all the 4 statements and then we see in the case of the ESC, select the correct answer using the codes below. So in GATE, if it is MSQ, I don't give that. I just go with the options. Now, what are the correct one? I keep 1 and 3. So we have to tick both the answers. You have to tick both the answers. See, in other words, what I say is, in ESC, whatever the multiple select questions, this is a multiple code questions are there or not. In ESC, the same questions would be modified as a GATE. That's it. I just give the options, so you have to pick out how many options are there. 1 and 3 are going to be the answers. Okay. Picked a question somewhere. So yes, so these are the remaining things that depends upon the next, the most interesting topic. So now let's go with the, see that's all about the channel transitions. I have attached one question over there that's missing, but I'll attach that later. So don't worry about that. I hope you understood the channel transitions. Okay. Now let's see the next topic, uniform flow. Sorry, gradually varied flow. So I hope you have been understood these things. Sir, can we leave the subject for gate, sir? You leave all the subjects for gate, right? Why you need to write the gate? Tell me. Do you need to write the gate? This is the question you are asking me. Can we leave the subject for the gate? If you want to leave the subject for the gate, then why would be I taking this subject? I would have said that earlier itself. No, you cannot leave this subject. This is very small subject and a very easy subject compared to the fluid mechanics one. Now let's come to the next topic. See, with this we completed everything regarding the specific energy and channel transitions. Now there comes gradually varied flow, GVF. So are we discussing about steady flows or unsteady flows? Are we discussing about the steady flows or unsteady flows? Steady flows only, right? So we are discussing about the steady flows. Now, what is meant by gradually varied flow? I have been explained clearly in the earlier classes. Whatever the discussion we are making is steady flows only. First of all, what is meant by? Yeah, it's a new chapter. So now coming to the gradually varied flow. And what is a gradually varied flow? Is it a steady flow that I am discussing or unsteady flow? Steady flow. So when do you say the gradually varied flow? So it's a steady varied flow happens over a longer span. Variation occurs over a length with smooth and less curvature with the smooth streamlines and less curvature. Okay, so the variation is going to be happens over a length with the smooth streamlines and less curvature, my dear. What is the meaning of a streamline, sir? The line that draws along the direction of flow. Whatever I am representing the flow like this. So this is nothing but the streamline. So the streamlines are going to be smooth. And what is the meaning of curvature, sir? The slope, variation of the slope is going to be very less, which means dou y by dou s is very less, but it's not going to be zero. Now, where do we observe this gradually varied flow? First of all, I told you clearly, out of all the flows, we discuss about the steady flows only. And in the steady flow, steady uniform flow is ideal flow. Yes or no? Steady uniform flow is the ideal flow. So now, whatever the steady gradually varied flow is the most commonly seen flow. Most commonly seen flow. So where do you find out this gradually varied flow, sir? Now let's see. GVF can observe in A simply back of an obstruction, back of an obstruction. See, what is the meaning of a back of an obstruction? I hope you remember the VRR barrage. You can see whatever, this is nothing but a VRR barrage, and I am providing you some channel bed slope over here. So now, my dear, you know, on the back of an obstruction, initially the flow is going to be uniform, and then due to the change of kinetic energy to potential energy, the water level is going to be rises. And you see, I have given this one as a gradually varied flow example while I was discussing about the classification of the flows. So, am I correct or not? See, this is nothing but a gradually varied flow or not, and this curve is known as a backwater curve. This curve is known as backwater curve. So, this is in the back of an obstruction. So, on the back of an obstruction, whatever we are going to get is nothing but GVF. There is one example, and second one, sudden drop in canal bed. See, this is not a gradual drop what we have discussed now. If there is a sudden drop in the canal bed, sudden drop. What is the meaning of sudden drop, sir? So you see here, there is a channel going, and if this channel bed suddenly drops like this, so whatever, this is nothing but a sudden drop. Okay, if the channel is going to be going, suddenly drop. You know that, my dear, forget about this drop for some time. When there is no drop, you know that the water surface is going to be goes uniform and with the same depth. Yes or no? But now, when I provide a drop, over here, so if I provide this drop, then what is going to be happen? Remember, this is drop means then there is no flow here. That's it. Then there is no flow. So beyond this, there is no flow. This is nothing but a drop. So now, my dear, can you tell me what is going to be happen in the case of the water surface? So you see, then the flow is going to be uniform up to a certain extent. From here, this is a drop, which is going to be a collector or storage. Then this water is going to be fall something like this or not? Yes. And when that water is falling, is it going to be fall suddenly or over a length? The water level is going to be falls over a length. Okay. So this water level falls over a length. And this is known as again gradually varied flow. Now see, I have given you two examples here itself. There are a lot of examples, other examples also there. Now we'll discuss that. But here the variation is rising or falling? Rising. Rising or falling? Rising. And here the variation is falling. Yes or no? So can I say this is nothing but a rising profile, and this is nothing but a falling water surface? Yes or no? Now the biggest question is, see, in this, sir, you are saying drop. I can say the water level is going to be fall, and this is the obstruction. I can say this water level is going to be rise. But how come I predict whether the water level is going to be rises or falls? Question number one: the gradually varied flow may be rising or may be falling. And how come you say something is going to be rising or falling? That is based upon the slope. What is that? That is based upon the slope. You know that if the slope is going to be positive, my dear, it's always rising. Yes or no? And if the slope is going to be negative, it is going to be falling. So the question number one is, in these two examples, I can say the water level is going to be rises or falls. But how come you predict exactly? Now let's see the next third example. See, whenever there is a change in a slope, whenever there is a change in the slope. Whenever there is a change in slope, now you see, for example, I'm going to have a initially very less slope, very less slope. What is the meaning of the lesser slope? Mild slope. And due to the topography, I have to change the slope to mild to steep slope. Mild to steep slope. Now, question for you is, do you think the water surface is going to be same throughout this? No. Whenever there is a change in the slope, now initially the water level is there, the water level may fall, or the water level may fall like this, or the water level may rise like this, or the water level may rise like this. You can see convexity, concavity or not. Yes or no? So you can see convexity, concavity. See, whenever there is a change in the bed slope also, then definitely water level is going to be varies over a length. And I don't know how this variation is going to be looks like. So does the variation is going to be rises or falls? That we need to predict. Understood or not? I hope you understood. Whenever there is a change in the slope also, there is a change in the water surface, and that happens over a length. That is nothing but a GVF. And you see, change in cross section or bed material. So this time what I do is I don't change the slope. This is a slope, channel bed only, but yet one section it may be a rectangle, yet some other section it may be a trapezoidal. So whenever the shapes are going to be changes, again the water surface, you know, the water surface is going to be changes or not. So whenever there is a change in the cross sections also, then the water surface is going to be changes. So I cannot say directly the water level rises, or I cannot say water level directly falls. So now we need to know the prediction or a behavior of the variation. See, these are the some of the examples I am giving you here, and I'm going to give n number of examples. I'll discussing all the practical scenarios in the gradually built flow, because the most commonly seen study flow is GVF, and this is very important in both the GATE and the IES aspect, especially in the case of the ESC. Especially in the case of the ESC, you see, so a lot of questions have been asked based upon this gradually built flow. So now, see, okay, sir. So now, my dear, this gradually built flow. So now let's see how we are going to find analysis. So what is the question that we required here is, see, from the given data, what I got to know is the first question that I want to look over here is whether the GVF is going to be rising or falling. Keep that in your mind, whether the GVF is going to be rising or falling. Okay, so how come I say whether the GVF is rising or falling, sir? If I know the slope, what is the meaning of this slope? Arey baba, this is a X, right? Yes or no? And this is a Y. So if I know the slope dou Y by dou X, if it is going to be pausing, if it is going to be passive, positive, then it is going to be rising. If it is going to be negative, then it is going to be falling. So the first thing is we are going to find out whether the slope is going to be rising or falling. So once I know the rising or falling, then I can say the GVF is rising up. Means once I know the slope is positive or negative, I can say GVF rising or falling. Number two, whether it is rising or falling, is it linear or a curve? Curve. So when it is going to be rises, the curve may be concave or the curve may be convex. The curve may be concave or the curve may be convex. Yes or no? So how come you predict whether the curve rising is going to be convex or concave? Question number 2. Question number 1, whether it is rising or falling. Question number 2, the curvature, whether it is going to be convex or concave. Now, and the question number 3 is it a GVF or not? GVF means happening over a length. So what is the length up to which the variation is going to be happen? What is the length up to which the variation is going to be happen? Question number 3. So how many objectives we are going to solve? 3. Number 1, slope dy by dx. Number 1, slope dy by dx. dy by dx. Number 2, it's a curvature. Number 3, length. So for all these 3 objectives, we are going to determine one equation. We are going to determine an equation, and that equation we are going to call it as a dynamic equation of GVF. Dynamic equation of GVF. So before going to the dynamic equation of the GVF, for every analysis, we require some assumptions. Yes or no? In the case of the specific energy concept, I usually I do assume like a channel bottom is horizontal and frictionless. I do assume if I discuss about the one transition, the other transition should be constant. Yes. And in uniform flow, while I was deriving the condition for the uniform flow, if you remember, I said flow is a steady, flow is a steady, flow is a steady. And pressure distribution is hydrostatic and hydrostatic. Similarly, here also there are some assumptions. Now, what are those assumptions are? First, let me write down the assumptions. Flow is steady. Second one is pressure distribution is hydrostatic. See, these assumptions are same that I have taken in the uniform flow or not? Same I have taken in the uniform flow. So flow is steady, pressure distribution is going to be hydrostatic. Pressure distribution is hydrostatic, okay? And now the third one is the most important one. Uniform flow equations can be used. Equations can be used. So what is the uniform flow equation, sir? What is the meaning of the uniform flow equation, sir? The meaning of the uniform flow equation, what is the uniform flow equation? Manning's equation, yes or no? And what is the Manning's equation? V is equals to 1 by n into r to the power of 2/3 into s to the power of 1 by 2. V is equals to 1 by n into r to the power of 2/3 into s to the power of 1 by 2. Sir, how come I use this equation in the case of gradually varied flow? See, if you go back and remember the uniform flow, let's go back to the uniform flow. Yes. So this is the uniform flow. And what is the uniform flow? The assumptions I have taken, pressure distribution is hydrostatic and flow is going to be steady. So whenever I say the uniform flow, the terms related to the uniform flow is Yn or Yn. So what is Yn? Normal depth or uniform flow depth. So whenever I say uniform flow, then Y becomes Yn. And what is S? S is equals to S naught. Yes or no? S is equals to S naught. Because generally the S means SF, my dear. The S means the slope means SF. The slope means SF. Okay. So in the case of the gradually varied flow, in the case of the uniform flow, the SF and S naught both are same. In the case of the gradually varied, uniform flow, SF and S naught both are same. So in uniform flow, I use S as S naught, Y as Ym. Okay. So in the case of the uniform flow, if it is going to be uniform flow, in uniform flow, the depth Y is equals to Ym and S is equals to S naught. Because in uniform flow, the flow depth is going to be constant normal depth and the bed slope is going to be parallel because total energy line is parallel to channel bed R naught. S is equals to, SF is equals to, or I can write S is equals to, SF is equals to S naught. But now we are discussing about gradually varied flow. So in the case of the gradually varied flow, what is Y? Y is not a constant. This is a variable flow depth. Variable flow depth. And what is a S? Here the S is going to be SF only and SF is not is equals to S naught. So if I say uniform flow in this equation, I'll keep S as a SF is equals to S naught, then Y is equals to Ym. The same equation, if I write for uniform flow, then Y becomes Yn, S becomes S naught. Keep that in your mind. Now, if I go for the gradually varied flow in the same equation, then Y is a variable flow depth, that's it. Means the variation is going to be happen. And slope, S is nothing, but in this we write, I have to use S as SF, not S naught. Because in the case of the GVF, SF is not is equals to S naught. Okay. Now, let's draw the figure. So now this is a channel bed. Let's take the water surface. This is a GVF, right? So when it is a GVF, the GVF may be rising or falling. You know, the water level may be rising or falling. But let me take the water level is falling like this. See, this is our awesome means I am taking for the analysis purpose. I am taking for the analysis purpose. I am taking. So this is a water surface. I am taking the falling water level. You know, this is nothing but hydraulic gradient line, and you know this is nothing but bed. And you know, in the case of the total energy line. So now there comes one more assumption. Here you cannot neglect the frictional losses. You cannot neglect the frictional losses. Keep that in your mind. Frictional losses should be considered. Frictional losses should be considered. So when I consider the frictional losses, then now you tell me, do you think the total energy line is falling? No. Do you think the total energy line is going to be, sorry, do you think the total energy line is going to be horizontal? No. The total energy line is going to be falling. So that is going to be the total energy line. Now, at a particular datum, can you tell me what is the total head at a particular section, please? What is a particular, at a particular section, this head V squared by 2G. What about this? Depth of flow. And what about this? This is a channel bed. And this is datum. This is channel bed and this is going to be datum. So now arbitrary datum. Now whatever, this is channel bed. Now the most important assumption, one more point I am going to say here is, I hope you can able to understand this. Now flow is going to be steady flow. whatever the flow, and the pressure is going to be a hydrostatic distribution. You can use the uniform flow equations. And the last assumption here is as a channel bed slope is very less, as a channel bed slope is very less, you are going to take the channel bed as a datum. You are going to take the channel bed as a datum or x-axis. As channel bed slope is very less, it should taken as, it should be taken as x-axis. So now what I want to write over here is, this is nothing but x. The channel bed is going to be x. So now from this data, I need to write down the equation. Yes. So can you please tell me what is the total head at any section? Please, can you please tell me what is the total head at any section? The total head H is equals to V square by 2G plus Y plus Z. V square by 2G plus Y plus Z. Okay. Now, say I want to study the behavior of this water surface. Yes or no? I want to study the behavior of the water surface, which means I want to say whether the water surface is going to be rising or falling. You see, in this case, the total energy line is always falling, and the hydraulic, the channel bed is also going to be falling here. Yes or no? Yes or no? Yes. And this water surface may fall or may rise. So now I need to know how this water surface is going to be varies along the length, which means, can I say, in other words, I need to know how this water surface is going to be varies means with respect to depth along the length x. So I want to study the dy by dx, variation of the depth of flow with respect to x. Now, what I do is differentiate with respect to x on both sides. With respect to x on both sides. So if I differentiate, then dh by dx, d by dx of v square by 2g, dy by dx plus dz by dx. Now what is meaning of this dy by dz and all those things? Now let's see what is the actual meaning of this one. dz by dx. So what is meant by dh by dx? What is h over here, please? The meaning of h is whatever this total head. This is nothing but h. What is meant by dh by dx? Variation of the total head, variation of the total head with respect to x. Variation of the total head with respect to x. Keep that in your mind. You are taking the total head. Then what is the slope of the total energy line? SF, right? What is the slope of the total energy line? SF. Okay. So the dh by dx means how the total energy line is going to be varies with respect to the x. Okay. So now can I write this dh by dx is nothing but SF, and as the total energy line is going to be always falling, now in this case assume the falling slopes are negative. Assume the falling slopes are negative. So can I write this dh by dx as, no, dh by dx as minus SF. Assume all falling slopes negative. Assume all the falling slopes are going to be negative. So dh by dx is equals to be minus SF. Okay. And then we go for the dz by dx. See, this is a dh by dx. dh by dx is the slope of the total energy line. Okay. And now dz by dx is the slope of the channel bed or not? See the total vertical ordinate from the total energy line to the datum H with respect to X is nothing but SF. Okay. And from the channel bed to the datum with respect to X, that is Z, dz by dx, then that slope is going to be S naught. SR means channel bed slope. And does the channel bed is a falling or rising? Falling. So as the channel bed is a falling along the direction of flow, then I can take then the dz by dx is going to be minus S naught. Minus S naught. Why I am taking minus is the total energy line is falling and the channel bed is also going to be falling. Now what is remaining is a water surface, right? Keep that in your mind. What is the SF? The total head from the TEL to this datum H with respect to X. And what about channel bed Z from the channel bed to the datum? Okay. Now what about the water surface flow from the water level to the datum? From the water level to the datum, what is this depth? Please tell me. From the water level to the datum, what is this depth? Tell me. Y plus Z. So d by means y plus z with respect to x, that is SW. See this total h with respect to x, TEL, SF. This z with respect to x, channel bed. Now if I want to go for the water surface, then from the water surface, y plus z with respect to x. The differentiation of y plus z with respect to x, that is going to be SW. But what I have is only dy by dx. What is mean by dy by dx? The variation of water surface depth, only the variation of the water surface depth with respect to whom? Channel bottom or with respect to x? With respect to x. With respect to x. So now where dy by dx is slope of water surface with respect to channel bed. Actually, if I want horizontal, with respect to horizontal means then it should be y plus z. It should be y plus z. So now from this, I got to know this one. Yeah. Okay. So now you please write down these things over here. You please write down these things. And apart from that, let's take this d by dx of v square by 2g outside. D by dx of v square by 2g outside. Can I write this one as d by dx of q square by 2g a square? Q square by 2g a square. Okay. Now q is constant, right? Q is going to be constant. So for this next one, I can write q square by 2g into d by dx of 1 by a square. D by dx of 1 by a square. See, keep that in your mind. Keep that in your mind. The a is a function of length or depth. A is a function of depth. A is a function of depth. Okay. So as a is a function of depth, now can you differentiate a with respect to x? Can you differentiate what is a? Area. A is nothing but cross section area, my dear. Cross section area depends upon depth of flow, not on the length. Yes or no? So as a is a function of y, I cannot differentiate with respect to x. For that, what I do is multiply and divide with dy. Multiply and divide with the dy. Then you can differentiate with respect to y. So now what I do is q square by 2g. You take this d by dx as a dy into 1 by a square into dy by dx. So now you take 1 divided to the inside, other the dx to the outside. Okay. Now, can you please tell me what is the differentiation of 1 by a square with respect to a? First, with respect to a, minus 2 by a cube into dA by dy into dy by dx. I hope you have done this similar to in the specific energy also. So if you take this as a channel, and if you take a small element at the top, this element, whatever the top width T, and this element this is going to be dy, then the elemental area dA is nothing but T into dy, and I can write T as a dA by dy. Okay, so now you can write down the top width as a dA by dy. 2 will get cancelled, minus q square into dA by dy, T by g into aq into dy by dx, dy by dx, minus q square into T by ga cube into dy by dx. I hope you understood. See that d by dx of v square by 2g I have converted in this form. Now as area is a function of y, I cannot differentiate with respect to x. So I differentiated with respect to y by multiplying divided with the y. Okay. Now everybody, what is a q square? What is the q square? Let me write down this one. So what is a q square by a square? What is the q square by a square? The q square by a square, which is nothing but v square. Yes or no? V square. Okay. So q square by a square is v square, and the top width by area. See, if a square gone, then t by a. What is a t by a? Then you take this t to the denominator, then it is going to be dr naught a by t hydroliter v square by gd. I can write this q square by a square as a v square into, take this t to the denominator a by t d, v square by gd. What is v square by gd? Fr square into dy by dx. Now you please substitute all these things in the differential equation. So let me write down the differential equation once again. dH by dx is equals to d by dx of v square by 2g is plus dy by dx plus dz by dx. Now, what is the dH by dx? The dH by dx is a minus SF. Minus SF is equals to, what is a d by dx of v square by 2g? The d by dx of v square by 2g minus fr square into dy by dx plus dy by dx, and minus, what is dz by dx? Minus s naught. Okay. Now let's send this s naught to the other side and take out the dy by dx common. So if I take dy by dx common, dy by dx into 1 minus fr square is nothing but s naught minus sf. And now what is final dy by dx? dy by dx is going to be s naught minus sf by 1 minus fr square. 1 minus fr square. S naught minus sf by 1 minus fr square. So this is the dynamic equation of a GDF. This is the dynamic equation of the GDF. Where what is the dy by dx, my dear? The dy by dx is nothing but slope of water surface with respect to the channel bed. The slope of the water surface with respect to the channel bed. Okay. So what is dy by dx? S naught minus sf by 1 minus fr square. Now, based upon this dy by dx equation, see why I am giving this derivation is because without knowing this one, you cannot predict the behavior. So, based upon this dy by dx, if dy by dx is, if dy by dx is positive, then we call it as a rising profile, which means water surface is going to be rising. rising profile, or we can call it as backwater curve. We can call it as backwater curve. Similarly, if dy by dx is going to be negative, if dy by dx is going to be negative, we call it as falling profile or drawdown curve. So once I know that dy by dx, what is meant by dy by dx? The variation of the water surface with respect to horizontal or with respect to channel bed. What is the meaning of dy by dx? The variation of the water surface depth with respect to the channel bed. So it shows the variation of the water surface with respect to the channel bed. So with respect to channel bed, if the dy by dx is going to be positive, then the water surface is going to be rising. If the dy by dx is going to be negative, then the water surface is going to be falling. If you don't want, you don't need to remember the derivation, but without the derivation, I cannot get this equation. If I write this equation directly, then it will be gone to mad for you. So that's the reason why I have given this equation derivation also. So dy by dx is going to be s naught minus sf by 1 minus fr square. Now, based upon this, I can say whether the curve is going to be rising or falling. You please have a look once. Now I am going to modify this equation further. See, the meaning of drawdown is falling. That meaning of drawdown is falling. If the water is going to be falling water surface, then it is going to be drawdown. Now, let me do some more modification over here. So I want to do some more modification. Now, in the case of wide rectangle, as you know, most of our analysis is about rectangular channels only. In the case of the wide rectangle, the hydraulic radius is equals to y and the hydraulic depth is also going to be y. Okay. Now, go back. What is one of the assumption I made? I can use the uniform flow equation, right? But if I say GVF, then should I have to take S as SF or S as S naught? S as SF. And if that SF is S naught, you are going to set as a uniform flow. But in the case of the non-uniform flow, means GVF, SF is not is equals to S naught. Now, let's see this. In the case of wide rectangle channel, you know that Q is nothing but area into velocity 1 by n into r to the power of 2/3 into s to the power of 1 by 2. Don't keep anything. Now, you just substitute the r value. So if I substitute the r value, Q is nothing but by into 1 by n into y to the power of 2/3 into s to the power of 1 by 2. Okay, let's take this Q b to the other side. If you take the b to the other side, you know small q is nothing but capital Q by b. Let's take to the other side. Then small q is equals to 1 by n into, you see, y into y to the power of 2 by 3, y to the power of 5 by 3 into s to the power of 1 by 2. Now, can I write this one further as s to the power of 1 by 2 q into n into y to the power of 5 by 3. Or I can write s is equals to q square n square by y to the power of 10 by 3. This is going to be fetches a very good equation for us. So now, in this equation, if you observe clearly, see, whatever this is nothing but s a slope. S is going to be slope. Yes or no? Now, can I write s is inversely proportional to y to the power of 10 by 3? S is inversely proportional to y to the power of 10 by 3. Okay. So now, if it is a uniform flow, y is equals to yn and s is nothing but bed slope as s naught, because If I say uniform flow, the depth is going to be constant. So I'm using a y as yn and s is equals to s naught. And if it is a GVF, you know, y is nothing but y, which is going to be the flow depth. That's it. Whereas s is going to be sf. So in the same equation, if I use y as yn, then s is equals to s naught. Or if you keep s as y as y only, then s is equals to sf. Now, can I write from this relation, my dear, s directly proportional to 1 by what to the power of 10 by 3, right? So now, can I write sf by s naught is equals to, you see here, from here, as s is inversely proportional to y, sf by s naught. What is the sf depth? Y. What is the s naught depth? Yn. So sf by s naught inversely proportional yn means s naught, whenever I write s naught, y becomes yn by y whole to the power of 10 by 3. Can I write like this? So sf by s naught is equals to yn by y whole to the power of 10 by 3. Whole to the power of 10 by 3, because s is inversely proportional to y, right? So I have written this form. Now, you know that Froude's number fr square is nothing but v square by gv. And in the case of the rectangle, this is v square by gy. Now, let me go further. Can I write this fr square is equals to, what is a v? You know that we can write v as a q by y. So I can write a q square by g into y square into y as a y cube. Now, if you remember the case of the rectangle, yc cube yc is equals to q square by g whole to the power of 1 by 3. Have remember this? Yc is equals to q square by g whole to the power of 1 by 3. Okay. So now, can I write this q square by g? Can I write this q square by g as a yc cube, please? Then from here, fr square can be written as q square by g is a yc cube by y cube. And I can write yc by y whole cube. Yc by y whole cube. Yes or no? So directly so now from here itself directly I can write fr square is nothing but v square means a q square by y square, and a q square by g means yc cube, right? Yc cube by y cube, yc by y whole cube. I don't want to go for further steps because you know, I hope you understood here. So v can be written as q by y, v square by y square into y cube, and q square by g is nothing but yc cube. So now let's write down the dy by dx once again. The dy by dx is nothing but s naught minus sf by 1 minus fr square. Yes or no? Now let's take s naught outside. Then 1 minus sf by s naught by 1 minus fr square. 1 minus fr square. So now you see the final equation of dy by dx is dy by dx is equals to s naught into, what is sf by s naught? 1 minus yn by y whole to the power of 10 by 3 by 1 minus, what is fr square? Yc by y whole cube. And this is the equation now which is going to be source for us to analyze the flow. See, at first I have derived this equation, right? This is actual equation. Now I am doing everything for whom? Wide rectangular channel. In the case of the wide rectangle, I have given this equation. This dy by dx is equals to s naught into 1 minus yn by y whole to the power of 10 by 3 by 1 minus yc by y whole cube. And in this dy by dx equation, how many depths are there? 3 depths. What are those depths? One is yn, normal depth. other one is a Y flow depth, other one is a YC critical depth. So this dy by dx depends upon three depths, Yn, Y and Yc. And what is the significance of this equation, sir? That we'll be discussing after a break. So have a break now. So we'll be discussing that after the break, 15 minutes. Have a break. I'm sorry. Yeah. Okay. So now finally we got the equation dy by dx, which is a governing equation to determine the gradually varied flow. So from this equation of dy by dx, now I can write that dy by dx is a function of yn comma yc comma y. Okay, so the dn by the dy by dx is a function of yn, yc and y. Now keep that in your mind for any given channel. For any given channel. Okay, so here if you take yc are going to be the constant steps. Any given channel, let's take. So this is a channel, my dear, and you're going to send some discharge of Q, and it has some roughness and it has some bed slope. Yes, ma'am. It has some bed slope. Yes, ma'am. See, let me take this as a wide rectangular channel. Let me take this as a wide rectangular channel. In the case of the wide rectangular channel, let's take a Q square n square y to the power of 10 by 3. Okay. Now you see, if I write y as a yn, then s becomes s naught. Yes or no? So now can I write yn whole to the power of 10 by 3 is equals to q square n square by s naught. Okay. So in the case of the rectangle, if it is a wide rectangle, see why I take wide rectangle is to make you understand the easier expression. Look, the normal depth depends upon whom? You observe over here, the normal depth yn depends upon whom? Whatever the discharge passing through it, and n roughness of the bed material, and s naught bed slope. So for a given slope at a given flow rate, for a given q, n and s bed slope, yn is a fixed depth. Yes or no? Yn is going to be the fixed depth. If you change the bed slope, normal depth changes. If you change the flow rate, normal depth is going to be changes. Okay. Now coming to the yc. What is yc? Yc is nothing but q square by g whole to the power of 1 by 3. Whereas critical depth exclusively depends upon whom? Q. Critical depth is not depends upon the bed slope also. So for a given flow rate, now I can write one point over here as note. For a given flow rate Q, comma n and s naught, always there exists two fixed depths. Two fixed depths. So what are those fixed depths? Yn and yc. Yn and yc. Okay. So for a given flow rate Q, n, s naught, always there exists two fixed depths, yn and yc, and this are equals or less than yc. So yn may be greater than or equals to or less than yc. Internet problem is there. I think there is some internet problem. Yeah, I hope now there is no lag. Is there any lag of video? Is there any lag of video? Please tell me. I hope now it has been rectified. So now I hope it has been rectified. So have a look now. Yeah. Yn is greater than or equals to or less than a yc. Okay. So now as a dy by dx is a function of yn and yc, in any channel for a given flow rate q and n and s naught, there exists are two fixed depths yn and yc. And based upon this yn and yc, we are going to classify the slope. We are going to classify the slope. Now there comes the classification of water surface profiles. See, the purpose of making this equation, this dy by dx and this assumptions is now there comes how we are going to classify the water surface Yeah, sorry, there was a problem with the internet from my side. So back. Yeah. So problem was there with my internet. Now, come to the classification of the water surface profiles and the slopes. As you know, the slope dy by dx depends upon yn, yc and y. Until for a given flow rate n and s naught, always there exists two fixed depths. Always there exists two fixed depths. So that is known as yn and yc. Okay. Now, based upon the based on yn and yc. Just now I said as yn greater than or equals to less than yc. Now you please observe from this yn is inversely proportional to s naught r naught. Yn is going to be inversely proportional to s naught. Okay. So now can I write from this for a given channel at one flow rate, you see, you observe over here please clearly. First one, I can say one point here. You see the yn depends upon q, yc also depends upon q. So q, and for various values of q's, yn may be greater than yc, yn may be less than yc, and yn may be equals to yc. For various, remove this and I can write one point over here. For different flow rate, for different flow rates, yn can be greater than yc or less than or equals to yc. And based upon this yn and yc, if you are going to say yn is going to be greater than yc, if you are going to say yn is going to be greater than yc, we are going to call that slope as a mild slope, my dear. What is the meaning of mild slope, sir? One more thing here, yn is inversely proportional to s naught r naught. As yn is inversely proportional to s naught, you can see what is the meaning of yn inversely proportional to s naught? Lesser the bed slope, more the normal depth. Lesser the bed slope, more the normal depth. Yes or no? So whenever the bed slope is very less, then the normal depth is going to be more. And if that normal depth is going to be more than yc, then we are going to call it as a mild slope. What is meant by mild? Very, very less bed slope. Okay. Second one, if yn is equals to yc, we call it as a critical slope. We call it as critical slope. And if yn is going to be less than yc, we call it as a steep slope. Sir, why we call this yn is going to be less than yc steep slope, sir? Now you see, s naught, if the bed slope is more, if the bed slope means if the channel bed slope is more, then the channel bed is so steep or not. If the bed slope is more, then the normal depth is going to be less. So if discharge changes, y and yc value changes. If s naught changes, y and yc value changes. And after all this, if you know these profiles, then you can say based upon these values, you are going to state whether the slope is going to be mild state or a critical state or a steep state. We are going to call it as a steep slope. So first one, based upon the yn and yc, I can say, based upon the yn and yc, I can say mild slope, critical slope and steep slope. Sir, how we are going to find out yn, sir? By using the Manning's equation. See, this is applicable only for the wide rectangle. Keep that in your mind. Don't apply this for every other values. This is applicable only for the wide rectangle. Sir, if I give you triangle, what happens, sir? You go to the Manning's equation. How I have got this equation first of all? I got that equation by substituting in the Manning's equation or not. You say just simply substitute the Manning's and you can find out the normal depth. So once you know the normal depth, And once you know the critical depth, you know how to find out the critical depth. For rectangle, q square by g whole to the power of 1 by 3. For triangle, it is going to be 2q square by gm square whole to the power of 1 by 5. So then we are going to classify the slope as a mild slope. So for a particular discharge, for certain discharge, the slope can behave mild, or it can be behaves like steep for other discharge, and it can be behaves like critical for another discharge. Now, for a given channel, it behaves like mild slope for one discharge, steep for other, and critical for another discharge. Which means if the flow rate changes, the behavior of the channel is also going to be changes. Or for a particular Q value, for a particular flow rate, if the bed slope changes, again the type of the slope is also going to be changes. Okay. So now, based upon this, let's see what is the mild slope and what is the steep slope. Okay. Let's go with the mild slope first. Now, what is a mild slope, sir? Mild slope means the bed slope is going to be very less. The bed slope is very less. Okay. So in the case of the mild slope, you know, for a particular discharge, whenever the discharge is going to be there, if I say he is going to be the mild slope, when do you say mild slope? When the slope is going to be yn greater than yc. And you know that yn and yc are nothing but the fixed depths. Yes or no? So along the length of the channel, yn remains same. Along the length of the channel, yn remains same. Along the length of the channel, as long as discharge is same, critical depth is also going to be same. So now, can I write the vertical depth is not inclined to the channel bed? This is yn, and this is going to be yc. So yn is going to be more than yc, and you take along the length of the channel, the normal depth is going to be same. And whatever the line that represents the normal depth, this is known as NDL. What is meant by NDL? NDL means normal depth line. Whatever the line. See, here also this is a normal depth, and here also this is a normal depth. So throughout the channel, the normal depth is going to be constant. If you join all those points, that is going to be the normal depth line. And similarly, if you join all those points, in the case of the critical depth, we call it as a critical depth line. So when do you say mild slope? When yn is more than yc, we say it as a mild slope. And in the case of the mild slope, NDL is above than the CDL. See, still I did not discuss about the flow depth. Did I? No. I am discussing based upon this yn and yc only. So based upon the yn and yc, I can classify the slope as a mild slope or critical or steep slope. Okay. Now, if it is a steep slope, means if the slope that I am going to provide, if it is going to be the steep slope, so when do you say steep slope, please? When do you say steep slope? When yn is less than yc, which means now yc is more, yn is less. So when yc is going to be more, then whatever the line that represents the critical depth is known as a CDL. Sir, why you are drawing them as a dotted line, sir? Sir, in reality, can you see these lines? In reality, can you see these lines? See, whenever I draw a line, those are imaginary lines. See, when I allow the flow, you cannot see the critical depth line. Do you? No. So that is the reason why I'm drawing these lines. See, these are NDL and CDL are going to be acts like a boundaries for me. A boundaries for me, because you see now, next point, whatever the line that draws along the normal depth, this is known as NDL. So you know what is meant by CDL? What is CDL? CDL means critical depth line. NDL means normal depth line. CDL critical depth line, NDL normal depth line. Okay. So now, based upon the YN and YC, I have classified this. Still, do you think Y is there? Yes or no? And what is Y? Y is nothing but a flow depth. Y is nothing but a flow depth. What is normal depth? Are Baba? For a given discharge, Yn is constant. For a given discharge, Yn is going to be constant. For example, you are sending 10 meter cube per second, Yn is constant. But if you change the discharge, then Yn is going to be changes. Yn means normal depth, which is nothing but uniform flow depth. Yn is normal depth, which is nothing but the uniform flow depth. So now, look over here, please. So where CDL is a CDL and NDL. Now, based upon the Y, let's come to this point. What I want to say now, based upon the Y value, now you see, look, YN and YC are fixed depths, but you know the flow depth is going to be variable depth. Flow depth Y is a variable from 0 to infinity. From 0 to infinity, because see, what is the meaning of rising profile? Rising is like this. And what is the meaning of falling profile? Falling is like this. This is rising and this is going to be the falling. When the water level is going to be rises now, the water depth is going to be tends towards infinity. When the water level is falling, the water level depth is going to be tends towards 0. So now what is going to be happen over here is, if you observe, in the case of the mild slope or steep slope, whatever this entire is nothing but a flow or not, whatever the entire is nothing but the flow. Now everybody have a look. When I allow some flow, when I allow some discharge, its actual flow depth may lies above NDL CDL, may lie. See, the actual flow depth may be somewhere over here. The actual flow depth may be somewhere over here, because if the flow is happening like this, the actual depth may be somewhere over here. The actual depth may be somewhere over here. The actual depth may be somewhere over here. See, what is the purpose of this NDL and CDL is, this divide the entire flow space into 3 zones. This divides the entire flow space into 3 zones. Okay. So what are those zones? Above NDL CDL. So this is zone 1, above NDL CDL. And this is zone 2, between NDL and CDL. This is zone 2, between NDL and CDL. And this is zone 3, below NDL and CDL. See, when the flow is going to be happen, the flow can be anywhere. The flow can be like this or like this or like this. The flow can be like this or like this or like this. So the flow can be anywhere, ranging from 0 to infinity. So that is the reason why I divided the entire flow space into 3 portions. And what are those 3 portions? And those portions are known as profiles. Those portions are known as a profile. So how many profiles are there here? If the flow depth is going to be lies above NDL CDL, that is one profile. Between NDL CDL, that is one profile, and below NDL CDL, that is going to be other profile. Similarly, if you observe, in the case of the steep also, the first profile is there, second profile is there, third profile is there. How many profiles are there? 3 profiles. Okay, and whatever the profile that is above NDL CDL, whether it is a mild or steep, this is above NDL CDL, this is above NDL and CDL, and between NDL CDL and below NDL CDL. So the entire flow can be divided into 3 profiles based upon these. Now those profiles are nothing but water surface profiles. So first I have classified the slopes. Now I am going to classify the water surface profiles. This is based upon the flow depth. Let's see. Based on flow depth. Okay. First profile. If flow depth lies above NDL and CDL. So whenever the flow depth is going to be lies above NDL and CDL, then we are going to call it as a profile number 1. So in this case, in the first profile, you know that Yn is going to be, so whatever the flow depth is greater than Yn, whatever the flow depth is going to be greater than Yc, because the Y value is going to be above Yn and Yc. Yes or no? Above Yn and Yc. So in this, whether you take a steep or a mild, if I say flow depth here, this is more than Yn, more than Yc. If I say flow depth here, this is more than Yn and more than Yc. Now, whenever the flow is going to be in the first profile, was saying about the water surface profiles, right? Now, you write down the equation, please, dy by dx equation. Let me keep the dy by dx equation aside. Dy by dx is equals to dy by dx is equals to s naught into 1 minus yn by y whole to the power of 10 by 3 by 1 minus yc by y whole cube. So this is dy by dx. And now you have already known this dy by dx, right? So from the based upon the dy by dx, this is the equation. Now, how many depths are there? 3 depths are there. Now I have all the 3 depths, please. Y is there, Yn is there, Yc is there. Now I am going to define the dy by dx. Come on, my dear. What is dy by dx? What is dy by dx? Come on, tell me. What is dy by dx? Here you see, if you observe in this y greater than yn, you see y is greater than yn. When y is more than yn, when y is, I want to say whether it is positive or negative. When y is more than yn, my dear, y more, yn is less. Denominator more, numerator is less. So total yn by y is less than 1. Yes or no? And 1 minus less than 1, 1 minus less than 1, the numerator is going to be positive. When y greater than yn, the numerator is going to be positive by, now come to the denominator, yc and y. Again, y is more than yc. So yc less, y more, yc by y is less than 1 or not? Again, 1 minus less than 1, positive. 1 minus less than 1, positive. 1 minus less than 1, positive. So what is mean by positive by positive? Positive by positive is a total positive, which means the first profile is a rising profile or a falling profile. Think and see. First profile is rising profile or falling profile? Rising profile. Always keep that in your mind. The first profile is a rising profile. Whether it is a mild slope or steep slope, it should rise, that's it. Here also it should rise, that's it. So now always the first profile is going to be the rising profile, whether it's a mild slope or a steep slope. I can say always first profile is rising profile. Okay, so this is about the first profile. And next, coming to the second profile, water surface profile. When do you say is the second profile? When do you say second profile? If the flow depth is going to be located between NDL and a CDL. If the flow depth is going to be located between NDL and CDL, so below, between NDL, see which is above, which is below, I don't care. Is it between NDL and CDL? Yes. If flow depth lies between NDL and CDL. But now, when I use the between, so now in the case of the steep, it is different. In the case of the mild, it is different. How, sir? Sir, if I take this point as a steep, this Y is going to be below CDL and above NDL. Yes or no? And in the case of the second profile in mild, Y is below YN and above YC. So now in mild and in steep. In mild and in steep. For the second profile, in mild and in steep. So in the case of the mild, Y is less than YN, Y is greater than YC. Have a look. Whatever the Y, depth, the flow depth is going to be less than YN, more than YC. Similarly, in the case of steep, Y less than YC, Y more than Y is more than YN, Y is less than YC. Now what happens to the dy by dx? Now the dy by dx here is, you see, when Y greater than YN, see, I understood, I hope you understood this point. This point is one point. If you understand that, then you can get anything. If Y greater than YN, Y is more, YN is less. YN is less than Y. So this total value is less than 1. 1 minus less than 1, positive. And if Y is less than YN, or Y greater than YN, numerator is positive. Y less than YN, numerator is negative. By Y greater than YC, denominator is positive. Y greater than YC, denominator is going to be positive. Similarly, here, what is dy by dx here? Y greater than YN, numerator is positive. But what about denominator? Y greater than YC, denominator positive. Y less than YC, denominator is going to be negative. Okay. So now, in the both the cases, dy by dx is going to be negative. See, anything positive by negative is going to be negative only, right? When do you say positive? Positive by positive, positive. Negative by negative, positive. But this is negative by positive or positive by negative. Both are going to be the negative. Okay. And can I say whether it is a mild slope or steep slope, always second profiles are falling or drawdown profiles. Whether you take mild slope or steep slope or critical slope. Whether you take mild slope or a steep slope or critical slope. Now similarly, now next come to the third profile or profile 3. So when do you say that's a profile 3? When do you say the profile is going to be 3? If flow depth lies below NDL and CDL. If flow depth lies below NDL and CDL. See, flow depth lies below NDL and CDL means simply Y is less than YN, Y is less than YC. Whether you take mild slope or steep slope, In both the cases, now let's come to the third profile. In both the cases, y is less than yc, yn. Y is less than yc, yn. So I don't need to say separately mild and steep. Now, when y less than yn, then what is dy by dx? Y greater than yn, positive, y less than yn, negative. Y greater than yc, positive, y less than yn, yc, negative. And what is negative by negative? Positive. And with this, can I say, always for any slope, third profile is rising or backwater curve. Rising or backwater curve. So this is the classification of water surface profiles. So how do you say the mild or critical or steep? Yn and yc. And based upon the flow depth, we can say whether the profile is going to be rising profile or falling profile. So always I can say first and third profiles are rising profiles. For any slope you take, first and third profiles are rising profiles, and the second profile is going to be the falling profile. I'll stop today's session here, because from here we need to do the rigorous analysis. So as we don't have time, and moreover tomorrow there is no class, so if I start, definitely you people will forget what is going to be tomorrow. And tomorrow the class won't be there for a open channel flow. For hydrology, it will be discussed in hydrology class. But whoever attending for the open channel flow now, there is no open channel flow class tomorrow. And for the hydrology class, that will be let you know by the corresponding faculty in the next class. At 10:30 you are going to have a class, right? So in 10:30 class, corresponding faculty is going to be discussed about that, about tomorrow's. Okay. Yes, that's it about today's class. Today I did not discuss much. Today I was looking over the problems, and I was making sure you understand the more amount of concept. So and one more thing, today is Friday, right? Tomorrow holiday, and day after tomorrow 7 a.m. to 1 p.m. Day after tomorrow 7 a.m. to 1 p.m. So day after tomorrow our class is going to be Sunday 7 a.m. to 1 p.m. The class is going to be open channel flow. Okay. Mr. Harish, you are asking what is the difference between y and yn. After all this discussion, you are asking what is the difference between y and yn. I'm sorry for that. Whatever that we classify yc and yn, that is based upon formula only. Yes. How come we find NDL and CDL, sir? Sir, if you find out the yn and yc, the normal depth is going to be measured by means of Manning's equation. I have written right. How I arrived this equation? Manning's equation. And this is by means of the critical flow. You know how to determine the critical depth. Don't use this formula everywhere, yn, because this is for wide rectangle. Okay, so now NDL and CDL are nothing to do with the TEL, right? Those are not TEL lines. So yeah, we can call the first one is also rising profile or backwater curve. Now let's I'm enabling doubt clearing. Let's have a doubt clearing session. Mr. Yash.
Hello, sir. Good morning, sir.
Good morning, Yash. Tell me.
Sir, here, sir, here, if y is equal to yn, then it is uniform flow, sir?
Yes, when y is equals to yn, that is uniform flow. That the conditions will be discussing.
Okay, sir.
Okay.
Okay, sir.
Yeah. Miss Lavanya, please speak out. Miss Lavanya. Miss Lavanya, please speak out. Mr. Nitesh, please speak out. Mr. Nitesh.
Hello. Hello, good
Yeah.
morning, sir.
Good morning, Nitesh.
Sir, actually, we have discussed about hydraulically efficient channel, sir.
What is the problem?
Sir, in third or fourth class. So, in type 2 channel, you have said that as a for a given area,
Uh,
we have derived a hydraulically efficient condition, sir.
yes, but for the type the area cannot be constant
How, sir?
because you see if I take a like a closed pipe like a sewer, okay,
Okay, sir.
and in that sewer if I run partially that is open channel flow.
Yes, sir.
If I run fully that is pipe flow.
Yes, sir.
Do you think the flow behavior is going to be same in both the cases?
No, sir.
No. So in the case of the closed sections, you cannot design, you cannot modify the channel width or top width, something like that.
Yes, sir.
But in the case of the open channels, you may raise the sides or you may increase.
Okay.
But in the case of the closed channels, you cannot do anything. You cannot keep those dimensions as variables. Okay.
Okay, sir.
Yeah.
So, area changes, sir.
Area will change because the dimension of
Yes,
the
sir. As,
is same. Well, when the depth is going to be changes, then area is going to be changes, right?
yes, sir.
Yeah.
So, sir, in a type 1 channels also, as a white changes, area will be changed, sir.
There is a possibility for us. You can modify the width. Na? See what is the condition for the hydraulically efficient rectangle? Width is equal to 2 times of depth.
2 times. Yes, sir.
Yeah, b is equal to 2y, right? There,
Yes, sir.
if I want to go for hydraulically efficient, for example, if I give a width of the channel is 10 meters,
Okay, sir.
then how much depth you will allow?
What is the discharge, sir?
Discharge. You don't need to
Area.
worry now.
Okay,
Discharge you don't
area,
need to
sir.
worry because b is equal to 2y, right? Yeah, b
Yes,
is
sir.
equals to 2y. That is a condition for the hydraulic efficient. B is equals to 2y. So if I provide a width
Yes,
of
yes.
2 meters, then what a depth should I have to send in order to make sure it is hydraulically efficient?
What is the width, sir?
Then what is y? B by 2, right?
Ah, yes, sir. Yes, sir.
See, it means if you send 5 meters of water, then that channel is going to be hydraulically efficient. Understood?
Yes, sir.
That's the reason why. See, you can, in the case of the type 1 channels, you have a flexibility. Either you can change the depth or you can change the dimensions of the channel before design.
Yes, sir.
But in the case of the closed channels, you have a flexibility of changing the details of cross sections. You can change depth, but you cannot change the details of cross section. You cannot change the dia of the.
Means the D. Acha.
Okay, that's right.
Okay, sir.
Okay.
Thank you, sir.
Okay. Next, Mr. Pavan Kalyan. Mr. Pavan.
Hello, sir.
Yeah, tell me, Pavan.
Sir, here we are discussing this profiles now, sir.
Yes.
In this, we are using dy by dx equation of wide rectangle channel only, sir.
No. See, we are taking why we are taking for wide rectangle is to give our data regarding. Am I giving you any values here?
No, sir. No, sir.
I'm just using that for the purpose of explanation. Okay.
Okay. This is
I want
like
to make it simple.
generalization.
Yeah, I want to make it for the simple generalize.
Okay, okay.
Yeah.
And regarding this energy curves in the channel transitions, there you have discussed y1, y2 variation with respect to channel hump or width. Like that, you have drawn graphs, no, sir.
Yeah.
Sir, in that it is like a little bit
This one?
confusing to decide the convex or concave.
Yeah, that's a spike, Nana. See here the convex and concave here. You forget about those things. You don't need to worry about those because we are not doing any mathematics on. Okay. Don't
Okay.
waste time on those things.
Okay. We just need to know that whether it is decreasing or increasing. That's it.
Yeah, that's it.
Okay. Okay. Fine, sir. Fine.
Okay.
Thank you, sir.
Yeah. Ms. Lavanya, please speak out. Lavanya, please speak out. Mr. Kalpesh, please speak out.
Hello,
Yes.
I'm audible, sir.
You're audible to me, my dear. Tell me.
Sir, in uniform flow, you said that y is equal to yn and s is equal to s0,
Yes.
and below you have written that in GPF y is equal to y. Then how that s is equal to sf? I'm having confusion, sir.
Actually, S is SF only. Actually, whatever this S
Uh,
is, you see,
Depth, I mean slope of total energy line.
actually this S is SF only. But in the case of the uniform flow, all the slopes are same or not? Hello?
Yes, sir.
In the case of the uniform flow, all
Yes, sir. Yes, sir.
are not.
Yes,
So
sir.
that is the reason why I took SF as S naught in uniform flow. But in the case of non-uniform flow, SF is not is equal
And
to.
in
Hello? Hello?
yes, sir. In GVF, s is equal to sf.
In GBF, S will not see. S means SF only, my dear. If I say slope, that is nothing but SF only.
Okay.
But in the case of
Okay.
flow, as all the slopes are same, I can take SF as directly S naught.
Yes, sir.
But in non-uniform flow, you see this total energy limit is parallel to the channel bed.
Yes.
Hey, see, is it exactly parallel to the channel bed or a little bit deviation is there?
Deviation is there.
Deviation is there means the total energy line slope is different and the bed slope is different or not?
Yes, sir.
So that's the reason why we don't take S naught in GF. See, in the case of, see, the meaning of S is SF only, okay? But in uniform flow, as all the slopes are same, then I can use this one as, instead of SF, I can use it as S naught, okay?
Okay, sir.
Yeah, I hope I understood.
Thank you, sir.
Yeah, okay.
Yes, sir.
Mr. Manjunath, please speak out.
Hello, sir.
Yeah, Manjunath, tell me.
Hello.
Yeah, tell me.
Sir, I have a small doubt in the discharge. Which transition, sir? Which transition supercritical flow, sir?
Tell me, what's your doubt?
Yesterday you tell, sir. You told.
Yeah, understood. Tell me what's
With the transition for the supercritical flow graph, sir. In
that's
that
what I'm showing.
small doubt, sir.
Yeah, this is for the supercritical flow.
Sir. Sir. In the graph, sir.
Yeah.
Graph, sir. Graph doubt.
This is for subcritical flow.
Sir. Supercritical flow, sir. I have doubt in supercritical flow.
So you want me to draw for the supercritical flow also?
No, sir. Supercritical flow graph, sir. I have doubt in the graph, sir.
This graph means what is the meaning of your graph, my dear?
Sir.
Huh? Yeah, okay, fine. Now you tell me. Yeah, I hope what you are seeing is correct one.
Sir, Q1, sir. Y1 is less than Y1 dash, sir.
Yes.
In that, sir, Y2 is equal to
Y2 is YC dash.
sir. Sir.
Yeah.
After the choke condition, how will graph will come, sir? Q2 is equal to Q dash max, sir.
That's what I mentioned, Nana. In order to occur the flow, this specific energy has to be increased.
Sir.
Due to the surge movement is there, right? The surge is there or not?
Sir.
The surge will create the
surge is there, sir.
Yeah, due to surge, it is going to be create unsteady nature. What is the meaning of unsteady flow rate?
Sir. Choke.
Then specific energy is also going to be changes. Okay.
Okay, sir.
That's it.
Thank you, sir.
Any other?
Thank you, sir.
Yeah, okay. I hope there are no other doubts so that I can leave. Mr. Harish. Mr. Harish, please
Good
speak out.
morning, sir.
Good morning, Harish.
సార్ ఇన్ దిస్ సార్ ఇప్పుడు డిస్ప్లే చేస్తున్న ఫిగర్ లోని
Hmm.
సార్ క్యూ మ్యాక్స్ అంటేనే మాక్సిమం ఫ్లో కదా సార్ క్యూ డాష్ మ్యాక్స్ అంటే ఎలా సార్
That's what I said. That's what I said, Harish. You please look over this point once again.
అంటే సార్ ప్రాక్టికల్ గా మనకు
Can you please tell me what is happening over here? Can you please tell me the third point?
స్పెసిఫిక్ ఎనర్జీ ఇంక్రీజ్ పెరుగుతుంది కదా సార్
Can you please tell me what is happening? The third point, first sentence. Q should be more than Q max, which is not possible. Yes, that's what I said.
ఎస్ సార్
But that is for given upstream specific energy, right? For the given E1,
ఎస్ సార్
for the given E1, that is going to be there. Yeah. For the given E1, this is the curve. Now, if I raise the specific energy, just if you remember, whenever we increase the discharge, what happens to the specific energy curve?
డిక్రీజెస్
Decreases, sir. Man, where are you? Tell me this. Tell me this. Have you gone through this graph or not? Have you gone through this graph or not? Whatever.
ఎస్ సార్ ఇంక్రీజెస్ సార్ క్యూ ఇంక్రీజెస్ నా స్పెసిఫిక్ ఎనర్జీ ఇంక్రీజ్
See, for a given graph is for a particular discharge. Yes or no?
ఎస్ సార్
If discharge increases, the curve is going to be rises or not?
ఎస్ సార్
Similarly, in the case of the width transitions also, now you see here, this is for a given specific energy even or not?
ఎస్ సార్
When I make sure E increases from E1 to E1 dash now, then what is
ఎస్
going
సార్
to be happen to the graph? The graph is going to be rises or not?
ఎస్ సార్
Now, when the graph is rises, there's the Q becomes more than Q maximum or not?
ఓకే
That's what. See, generally for the given upstream specific energy, it is not possible. But
ఓకే
if you increase the upstream specific energy, then it is possible. Okay.
ఓకే ఓకే సార్
That's it. Mr. Shankar, please speak out.
Hello,
Mr. Shankar, please speak out.
sir. Am I audible, sir?
Yeah, you're audible to me.
Sir, I have a small doubt, sir, regarding the sir in channel width reduction and bed rise, sir.
Hmm.
In both the cases, surge will be created, no, sir.
Yes.
So for the flow to occur, the specific energy should be increased.
Yes.
Due to that, the surge will be generated and black backflow will be taken place.
Yes.
Sir, then how the flow will occur, sir? The flow will be backwards, no, sir.
Yes.
If it is then the flow of
That's
water will
what
be
now we are engineers. We should not create such conditions because once the
okay.
sun comes on the downstream side, it is critical, right?
Yes, sir.
Critical means highly unstable nature.
Okay, in order to not to create the condition.
We need to know certain limitations, right?
Oh, okay. That is the delta ZC.
Yeah.
Okay, sir.
We cannot provide more than delta ZC, or we cannot allow any flow that should create the surge.
Okay, sir.
Okay?
Thank you, sir.
Yeah. Okay, man. So that's all for today, and I'll be leaving. I'll meet you on Sunday.